Good evening, students. I appreciate you finding time to get your notes taken care of. These are the notes for Tuesday's class, October the 1st. We are getting into actually what is the second half of Unit 2. We kind of broke it in half so that we could get a test in before the end of the first 6 weeks, which we needed to do. Now, the second half is going to be a continued discussion of parent functions and changes that can be made to the parent functions, and a large part of that is going to revolve around the topic of inverses. So let's begin. Your objective for the day: the student will learn the basic process for discovering the inverse of an equation. Again, these are the notes for October 1st. Please copy down your objective and the date, and press pause anytime you need extra time, and then press play to move on again. These notes will not take long. The very first steps of this are really pretty straightforward. Okay, the inverse of a function is found by reversing the variables in an ordered pair and re-solving the equation for y. Now, you may recall back in the day when you were first going through Algebra 1 or maybe even pre-algebra, the x and the y terms had names. They were called the abscissa and the ordinate. X was abscissa, ordinate was y. What an inverse is going to do is it's going to switch the abscissa and the ordinate in the equation, and then it's going to resolve for the ordinate. It will give us a new equation, which we will learn has various properties, and we'll get to all of that. Okay, but an inverse of a function is sometimes abbreviated by what looks like an exponent, and it is a -1 exponent. So a function f could be abbreviated as f to the -1. It's called an inverse. Okay, now, so let's take a look at what we've got going on here. Okay, here is a function. If f of x equals 3x plus 7, and I'm missing my little inverse. There it is. Okay. If f of x equals 3x plus 7, then find the inverse of f of x. Okay, well, this is a simple linear equation. It is linear because we have y to the first and x to the first. What an inverse is going to do, as we said, it is going to switch the positions of the abscissa and the ordinate. So x and y are going to switch places. So instead of y equals 3x plus 7, the inverse will read x equals 3y plus 7. Now what we do from here is we're going to take this new equation, x equals 3y plus 7, and we're going to re-solve it for y. Okay, so here's where we get back to our 5 steps for solving an equation. Remember my silly little saying, parents' complaints vary for everyone. Okay, we're going to walk through that trying to get y re-isolated. Okay, so x equals 3y plus 7. Parents' complaints vary for everyone. Parents, parentheses. Do we have any parentheses or multiplication to deal with? We do not. Complaints, combine like terms. On the right side of the equation, you have a binomial 3y plus 7. Can the 3y and the 7 be combined? No, they cannot, so they are not like terms. Vary, that means get all your variables on one side. Well, the variable we are focusing on is y. Do we have y's scattered all over the place, or are they already all together? They're all already over on the right side of the equation, so we do not have to move any y's. Everything else goes the other direction. So if the y's are on the right side, then everything else needs to come to the left. So the first thing we're going to do is move that 7. How do you move that 7? Do the opposite of add 7, which is subtract 7. And of course, whatever we do to one side, we have to do to the other. Okay. On the left side, will the x and the -7, will they join together as like terms? They will not. X's want to add and subtract with other x's. Constants want to add and subtract with other constants, so they will stay apart. And that brings us to the final step of 1. That means we need to get a 1 and 1 coefficient and exponent for our variable. Right now we have 3 y to the firsts. We do not want 3 of them, we just want 1 of them. So we will move the 3 and leave the y. In order to do that, we have to split them apart. What is happening in between the 3 and the y? They're being multiplied, the opposite of multiplication. is division. So we will divide the entire thing by 3, and that will give us a third of an x minus 2 1/3, and y is now isolated again. I just swung the equation around. Usually I like to have my isolated variable over on the left side, but it really does not matter which direction you have written it. Once y is isolated once again, now you have your inverse. So if your entire goal was just to find the inverse of the equation or the function, there you have it. 1/3 of an x minus 2 1/3. Okay, you'll notice that the problem started off linear and it ended up linear. That will not always be the case with some of the inverses we will run into, but again, you'll see that a little bit later. Okay, let's look at one that's a little bit more complicated than just linear. Obviously, this one is a square root function. If f of x equals the square root of x minus 2, find the inverse of f of x. Okay. Well, we have a square root function. It has a little bit of a phase shift, 2 units to the right. Okay, but here we go. What will the inverse read? Instead of y equals the square root of x minus 2, the inverse will read x equals the square root of y minus 2. Now, our challenge is to get y re-isolated. So the first thing you should notice is that y is underneath underneath a square root. Okay, we cannot get to y unless the square root is removed. This is the first step of the 5 steps. Parents' complaints vary for everyone. This is similar to a parenthesis issue. Our y is being held to the -2 by the radical. So what we need to do is we need to do the opposite of square root in order to get that radical off of our y. So what is the opposite of taking the square root of something? The opposite of square root is square. We're going to square the right side of the problem in order to cancel the square root. But of course, whatever we do to one side of the equation, we have to do to the other. Okay, so we will have x squared on the left. On the right, the square and the square root will cancel each other and leave just y minus 2. Now we are free to get to the y so that we can isolate it. Okay, so that takes care of the parent's problem. Okay, complaints? Any combining like terms? No. Variables all on one side? Yes, the y's are already all together. Everything else the other direction? We've got a little bit of a problem there. That minus 2 does not need to be attached to our y. So how do you move the minus 2? Add 2 to both sides of the equation, because whatever we do to one side, we have to do the other. On the left side, will the x squared and the plus 2 combine? They will not. They are not like terms. So we will have x squared plus 2 on the left, and y is now isolated on the right. Once you have y re-isolated, this is your inverse. The inverse of f of x is x squared plus 2. So in this one, you can see that we started off with a square root function, ended up with a quadratic function. Okay. We're going to explore that a little bit further as we go deeper into inverses, but just be aware that you will not always end up with the same type of function that you started off with, but you will learn to see that some of the behaviors between the two, the function and its inverse, they're very similar to each other. Okay, now I don't necessarily have anything for you to do on this one in your notes, but I'd like you to copy it. Okay, if g of x equals 3x minus 7 quantity squared plus 2, find the inverse of g of x. Okay. I'd like you to copy this one down and give it a try in your notes. We will look at the solution to this one first thing in class on Tuesday. So copy it down, give it a try, and then in class we will see if you are correct. Again, I appreciate you finding time to take your notes. Let's see if we can't get off to a better start in the second 6 weeks than we did in the first 6 weeks.